Okay, so to perform the elephant toothpaste experiment, you're going to need a conical flask, dish soap, a 50 milliliter beaker, a 10 milliliter beaker, 30% hydrogen peroxide, potassium iodide, food coloring, an 80 milliliter beaker, a wave boat, a wooden stir, and a scupula, and a large dishpan.
Alright, so the first thing you're going to do is you're going to measure out about 5 milliliters of water and 10 grams of the potassium iodide. And you're going to combine them in a beaker. And then stir the solution until they dissolve. So after the potassium iodide solution has been dissolved, you're going to add about 2 drops of food coloring, which isn't necessary, and then about 5 milliliters of dish soap. After you mix in the dish soap, it's going to get kind of pasty, but that's okay. You can just go ahead and pour it in the conical flask.
Okay, so you're going to measure 50 milliliters of hydrogen peroxide and then pour it in as fast as you can, and then just watch the reaction happen. The 2,000 milliliter flask used in the experiment is shown. It is composed of 2 three-dimensional shapes, a cylinder and a frustum, which is a cone that has had its upper part cut off. The cylinder has a height, h2, of 2.54 centimeters and a radius of 1.5 centimeters, represented by the lowercase r. The frustum has an unknown height, h1, and a radius of 8 centimeters, represented by uppercase r. The given rate in this problem is the rate of change in volume, which is 280 milliliters per second, which is equivalent to centimeters cubed per second. The reason for this conversion is because the dimensions of the flask were measured in centimeters. The unknown rate that we are trying to solve for is the rate of change of the height.
The first step to solving for the unknown rate is to write an equation that relates the variables. In this case, it is an equation for the volume of the flask. The first part of the equation for volume accounts for the volume of the frustum. Pi times 1/3 times the height of the frustum, all multiplied by the quantity of the first radius squared plus the second radius squared plus the product of the 2 radiuses. The second part accounts for the volume of the cylinder. Pi r squared times the height of the cylinder. Once the quantities for all of the known variables are substituted, the equation for volume can be simplified to 81.94 times the height of the frustum plus 17.95.
The next step is to take the derivative of the equation for volume that we just calculated. After that, substitute the known rate and manipulate the equation to solve for the unknown rate. The solution for the rate of change of the height is 3.43 centimeters per second.